All right, so in this activity, we are going to be looking at an introduction to derivative rules. So far, we have been able to find the derivative by looking at the limit of rise over run as run goes to 0. We have been calculating the derivative always from the definition. Anytime in mathematics when your strategy is the same, if you do it to a function in general, or a rule falls out. And so the class, although we're still after the same question, how do I find the slope of the tangent line? My strategy is going to be very different. We're not going to be calculating that limit anymore. We're going to be using a rule. So the flavor of the class is changing. It's more about looking at a function and saying what rule or what rules apply here, and then applying those rules. All right, so in this activity, we're going to be looking at derivatives of polynomials. Constant functions are polynomials, and we're also going to be looking at sums and differences of differentiable functions. And your good old exponential function e to the x, that's all section 3.1 in our text. And then we're going to look at product rule and quotient rule, that's 3.2. This is about finding the derivative of a product of two functions multiplied together, or the quotient of two differentiable functions being divided. All right? In this first video, I'm going to break this up into a lot of short videos so that people could jump to the section that they need. In this video, we're going to go ahead and do this warm-up and page 1, which gets us through example 1 here. Okay? So let's jump in. What is the geometric interpretation for the derivative f prime of x at x equals 1? Remember, f prime is giving me the slope of the tangent line to what curve to y equals f of x, wherever when x is 1. So you could say at the point 1, comma, go find y, f of 1. Okay? So with that in mind, let's consider this constant function, f of x is always 3, or y is always 3. So here's f of x. Y is always 3. And first, I want us to go ahead and think about what f prime of 1 is. F prime of 1, again, is the slope when x is 1, and where are we? Right now we're at the point when x is 1, what's y? Y is 3. So what's the slope right there when x is 1? Well, it's a horizontal line. The slope is always 0. In fact, let's write that. The slope is 0. So what? So f prime of 1 is 0. Now my second question is, does that value of the derivative change for other values of x? And the answer is no. For any x, how about x is minus 3? But for any x, what is the slope going to be of the tangent line? Well, it's always going to be 0, regardless where you are in the domain. In fact, f prime of x is 0 for all x, for any real number, for any x in the domain. Right? So all these slopes are 0. And that'll be true for any constant function, because all constant functions are horizontal lines, and the slope of a horizontal line is 0. What about this line, the line y equals y equals x? F of x equals x. Here's your y equals x. First, find f prime of 1. That's saying, what is the slope of the tangent line to the line y equals x when x is 1? Well, when x is 1, we're right here at the point 1, comma, go find y, 1, comma, 1. Well, the slope right there, the slope is 1. The slope of the line y equals x is 1. So what? So the derivative at 1 is 1. The second question, does that value change for other values, for values of x other than 1? And the answer is no. No matter where you are in the domain, you know, maybe we're over here. No matter where you are in the domain, drawing a little small, the slope of that line is always going to be 1, right? In fact, the derivative of x is 1 for all x in the domain. Why? Because the slope of the line y equals x is 1 everywhere. Maybe we write that. I don't know if I want to keep writing in green. That's okay. Everywhere. Right? Just like here, the answer was 0. The slope of the horizontal line, y equals 3, is 0 no matter where you are in the domain. Let's write that. Okay. In general, for any line y equals mx plus b, what's f prime of x going to be? It's going to be m. The slope of a line is constant. It's always, always m. Right? For any line, y equals, or f of x equals mx plus b, what's f prime of x going to be? F prime of x is going to be m, no matter where you are in the domain. And that's true for all x's. Yeah. Okay. So, with this geometric understanding of the derivative being the slope of the tangent line, we actually just came up with our first derivative rules. I'm going to introduce a little bit of notation that d dx is called the derivative operator, and it's telling you to go ahead and take the derivative. This is saying take the derivative, this is saying take the derivative of, this is saying take the derivative of whatever function they write immediately after. So here, this is saying take the derivative of 3. Take the derivative of the function y is always 3. F of x is always 3. Which we've already done. of what? Of f of x is 3. The function that we write right after it. And we know from our little warm-up that the derivative of a constant is, in fact, 0. The derivative of 3 is 0. Maybe I even just write that. Y, the slope of a horizontal line, is 0. That's true for any horizontal line, not just y equals 3. The derivative of any constant, right? Oops, highlighter. A constant just means a number, right? C is a number. The derivative of any constant is 0. Why? Since the slope of a horizontal line is 0. And the derivative of any line, mx plus b, the derivative is just going to be m. Okay? So this is just our warm-up, but we're practicing seeing that d dx notation as saying, oh, take the derivative of the function that follows right after. Okay? So this is saying, this is provoking in me a question, and that question is, what is the derivative of minus 5x plus 33? And if you want to write y equals instead of f, you can too. How about we do that? Of y equals minus 5x plus 33. That's the question. Well, we know the derivative is the slope. The slope of the tangent line. And the slope of a straight line is constant everywhere. Answer, minus 5. I could have also asked you this question another way if I said that f of x or y was minus 5x plus 33. I could ask you to go ahead and find f prime of x, right? It'd be the exact same thing. We're just getting used to that derivative operator notation. Delightful. Okay, one more. Find f prime given that f is 11 minus 2/3 x. Oh my goodness, f is a line. 11 minus 2/3 x is the same as minus 2/3 x plus 11. That's a straight line. I can see my answer. The slope is minus 2/3. F prime of x is your negative 2/3. Okay, done. I could have asked you that another way with the derivative operator notation. We could have said just d dx of 11 minus 2/3 x. Oh, it's minus 2/3. Again, this is just a question. Take the derivative of the function here in parentheses or brackets, the function that follows immediately after. All right, so that concludes this video. In the next one, I am going to be looking at power rule.